Most people interact with large language models every day now. You ask a question, get an explanation, and maybe even have what feels like a real conversation. And naturally, you start to assume, okay, this thing is thinking. Maybe not in a human way, but still, it's reasoning through problems, forming ideas, deciding what to say next. That assumption makes sense. The outputs feel intentional. It feels structured. Sometimes it even feels insightful. But what's actually happening under the hood? It's very different from what we normally think of as thought. And once you understand that difference, two things happen at the same time. AI becomes less mysterious, and its limitations become a lot clearer. So in this video, we're going to walk through how large language models actually work, what people mean when they say they think, and exactly where that illusion starts to break down. When people say a large language model thinks, they're usually describing the experience of using it, not the mechanism itself. The model responds coherently. It follows instructions. It explains ideas step by step. It adapts its answers based on context. Those behaviors overlap with what we associate with reasoning. So your brain fills in the gap and assumes there's some internal thought process happening behind the scenes. But this is where we need to separate behavior from process. A calculator can give you a correct answer to a complex equation, but we don't say it understands math. A GPS can reroute you around traffic, but we don't say it understands cities. Language models sit in this same category. They produce intelligent-seeming behavior without possessing understanding in the human sense. To see why, we need to look at how they generate text in the first place. At its most basic level, a large language model does one thing. It predicts the next token. A token isn't quite a word. It might be a whole word, part of a word, or even punctuation. But the idea is the same. Given everything so far, the model asks, what token is most likely to come next? That's it. No goal, no belief, no awareness of meaning, just probability. So if I write the capital of France is, the token Paris has an extremely high probability of coming next. The model outputs Paris. Not because it knows France has a capital, but because statistically, that sequence of tokens is overwhelmingly likely. Now here's the thing. Every response, short or long, is built by repeating this process, token by token, thousands of times. You ask a complex question, and the model starts generating. First token, then the next, then the next. Each one chosen based on what's most likely given everything that came before. That's the foundation everything else rests on. So if language models are just predicting tokens, why do they sometimes appear to reason step by step? Well, the answer lies in the patterns they learn during training. So during training, the model is exposed to massive amounts of text, explanations, arguments, proofs, tutorials, conversations, thoughtful human reasoning. Over time, it learns that certain token patterns tend to follow others. For example, it learns that when a question is asked, an explanation often follows. When a problem is complex, people often break it into steps. When someone says, let's think this through, structured reasoning usually comes next. So when you prompt a model to explain your reasoning, it doesn't activate some reasoning module. It activates a pattern. It generates text that looks like reasoning because reasoning text appears frequently in its training data. This is why chain of thought responses feel so convincing, but they're still generated the same way, token by token, based on likelihood. This pattern matching ability is impressive, but it's also where we need to be careful about what we're actually seeing. Here's where the illusion becomes strongest. When a language model explains something clearly, we tend to assume that it understands the concept the way a human would. But understanding requires something language models don't have: grounded experience, internal goals, a persistent mental model of the world. A language model doesn't know what a chair is. It knows how the word chair is used in sentences. It doesn't know what pain is. It knows how people talk about pain. It could describe the sensation of cold perfectly, the way your skin tightens, the way you shiver, without ever experiencing temperature. This is sometimes called symbol manipulation without grounding. The model operates entirely in the space of symbols, words, and patterns, not lived experience or conceptual awareness. That's why a model can explain grief beautifully without ever having felt it, or describe physics without any sense of physical reality. The output can be accurate, poetic, even insightful, but it's not rooted in understanding. The limitations become obvious when we push beyond familiar patterns. Here are 3 common places where the illusion breaks. First, novel situations. If a problem is genuinely new, outside common patterns, the model struggles. It may sound confident while being subtly wrong, because confidence itself is a learned pattern. Second, long-term consistency. Language models don't maintain a stable internal worldview across long conversations. They don't remember beliefs the way humans do. They track context statistically, not conceptually. That's why answers may contradict earlier statements. Preferences may shift mid-conversation. Logical consistency can drift over time. Third, causal reasoning. Models are good at describing cause and effect, when that description appears frequently in training data. But when you ask them to reason about causality in unfamiliar domains, they often fail silently, producing fluent explanations that don't actually hold up. And that's the key thing. The illusion doesn't break with nonsense. It breaks with plausible errors. Understanding these limits doesn't make language models less useful. It makes them safer and more effective to use. When you treat a model like a thinking entity, you risk over-trusting outputs, missing subtle errors, assuming intent where none exists. When you treat it like a pattern engine, you gain clarity. You start asking better questions. Is this answer verifiable? What assumptions is this response following? Does this require real-world grounding? This shift is what separates casual users from effective operators. Once you understand how the system works, you can align with it. Instead of vague prompts, provide structure. Instead of trusting fluency, validate accuracy. Instead of asking it to think, ask it to show its steps, knowing those steps are generated patterns, not internal reasoning. Language models are best used as drafting partners, explanation generators, pattern expanders, thought scaffolding tools. They're not decision makers. They're not sources of truth. They're not independent reasoners. That distinction matters. Large language models don't think the way humans do. They don't understand, intend, or reason internally. They predict language exceptionally well. The reason they feel intelligent isn't because they possess thought, but because human thought has left behind a massive trail of language patterns, and the model has learned to follow them. Once you see that clearly, the mystery fades, and what's left is something more useful than hype. A powerful tool with clear strengths and equally clear limits. Understanding both is what allows you to use AI well. Will this change the way you use large language models? Drop a comment, subscribe for more AI truths.